Okay, ladies, let's start. So, ladies, I'm going to go over the solution to the. Remember, I asked you guys to look at the 7 skulls. I'm going to go over like what you need to know in regards to the 7 skulls. Okay? Nope. No, it's not another lab. This is the one I asked you to look at. The characteristics for the gorilla, the chimp, the 2 Australopithecines, and the 3 members of the genus Homo, if you remember, okay? We're going to look at things like sagittal crest, the size of the eyebrow ridges, the shape of the teeth, the number of teeth, the width of the cheeks, whether or not they have a forehead, the location of the foramen magnum. Okay, those are the things we're looking at. So what I'm going to do is, what's more important for me is for you guys to see the pattern and be able to use the data to make your own tree, okay? So what we're going to do is we're going to make a tree. Now, you guys are making a tree using genetics. And this is going to be a tree using the characteristics, okay? The ones that you collected. So, first thing we're going to do is I'm going to help you a little bit in terms of, I'm going to tell you basically what the tree would look like, okay? And then we're going to see if we can figure out what characteristics would fit where. So, this is a tree, and here we would put 7 specimens. So I'm going to put Homo sapiens here. So I'm going to put H sapiens over here. Let me make this a little bit thinner. Hold on. Okay. And I'm going to put H Neanderthals here. Okay. And I'm going to put Homo erectus here. And I'm going to put, I'll explain all of this in a second. I'm recording this, so. A. afarensis. And the other one was A. boisei, right? Okay. And then I'm going to put the chimp here. And the gorilla here. Okay. Now, you collected a whole bunch of data. So, I'm going to ask you a bunch of questions, see if you guys can figure this out, alright? By looking at your data, what distinguishes this side of the tree, so from here to here, from the gorilla and the chimp? What's different when you look at the data? What's different about the gorilla and chimp when you compare it to those other specimens? Afarensis, boisei, erectus, Neanderthals, and Homo sapiens. Yeah. We can't see that by looking at the skull, though. But there is a clue. There is a clue in the skulls. What is it? What's that called? Okay. So, we could say that the gorilla and chimp, we know that they're not bipedal. And there's a clue in that. If you look at the bottom of the skull, there's a hole. It's called the foramen magnum. Oops. Sorry. Is that? No. This is a different assignment. Now, what we notice is it's shifted forward. Okay? In all of the specimens from Afarensis to Homo sapiens, that hole is shifted forward. It's not nearly as it is. If you look at gorilla and chimp, it's really far in the back. But if you look at the other specimens, it's shifted a bit forward. So what we could say is that what makes these 5 different is that foramen magnum is shifted forward. Now, you guys know how to read these trees, right? Okay. Remember, think of this as a tree. These are the tips of the branches. And how do you read how closely related things are? Like, according to this tree, why is erectus more related to us than Boisei? No, but why though? How do you know that? By looking at it. Yep.
Because their point closer to us than the base doesn't.
Has to do with the height of the point. So, yep. So, for example, if you look at humans, remember you look at where they're connected, okay? Where's the point that connects humans and erectus? Where is it? It's right here, right? Where's the point that connects humans with Boisei? It's right here. The higher up the point is, the more closely related they are. Give an example. Look at humans over here on the right. Humans are here. Chimps are here. Gorillas are right beside them. Which two are more like each other? Nope. Not chimps and gorillas. I understand. But look at this. Use the exact same logic. Humans are here. Chimps are, wait, hold on. Humans are here. Chimps are here. The branch point that connects them is here. Where's the branch point that connects chimps and gorillas? It's further back. Okay? So you have to look at not where they are in the tree, it's where they're connected on the branch point. Okay? So be careful. Okay. So I've made the tree for you. What we're going to do is we're going to fill in the data so we can understand what the data tells us about the tree. So we know that, we know the foramen magnum is shifted forward, but what else is different when we compare the gorilla and chimp versus those other 5 specimens? Is there anything else that the other 5 have that the gorilla and chimp don't have? Dental arcade? Do you guys agree with that?
Wait, are you talking about the first 5? Or like...
So when we compare these 5, what do they have in common that gorillas and chimps don't have? Ah, yes. So one is the foramen magnum, but another one is the small canines. If you look at your gorillas and chimps, they have really big canines. And if you look at the other 5, they don't. What about the shape of the teeth? Or shape of the arcade? That one, I think you guys, some of you were debating that one, right? Is it straight for who? So did you guys say that these look pretty straight? You got straight for these guys? The other way around, you mean? So who had curved dental arcade? Who had it? So I have efferensis here. Well, I have Boisei here. I have afferensis here. So it looks like, yeah, these guys look pretty straight compared to the other one. So I would say, yeah, that one doesn't look like all of them have it in common. It looks like we don't start to see curved until here. But that one is a bit debatable. So let me explain how you read this now. Okay. This branch point. What do you think that would represent? What do you think that branch point represents? Common ancestor of what? Afarensis, Boisei, Erectus, Neanderthals, and Homo sapiens. Because they're all connected at that point. What about this branch point? Common ancestor. Sorry, that's the common ancestor of Erectus, Neanderthals, and Homo sapiens. So, the way how you put down the characteristics is quite easy. If all of them have it you look at a group, right? So, for example, with the small canines, all 5 of these have it. So we can say that the common ancestor probably had small canines. So we can put that characteristic where the common ancestor is, right about here. Okay? Gorillas and chimps don't have it because their common ancestor probably didn't have it. What else can we put maybe to distinguish the genus Homo from Afarensis and Boisiae? Right. So if you look at the top of the skull, you see those suture lines? All right. Again, we can say, because Erectus has it, Neanderthals have it, and Homo sapiens have it, we can probably say that the common ancestor had that feature. Okay? Because they all have it in common. Anything else when you look at your data? Where do you see a forehead? Okay. I heard that. Someone said about they all have. So where would you put that then?
Under all of them.
Very good. So if you look at the number of teeth, they're all the same. So if they all have that in common, we can put that at this point. We could say that the common ancestor of all of these specimens probably had that in common. Okay? Very good. Anything else maybe we can put on this tree? Now, when you guys are looking at the foramen magnum, right? Between Afarensis and Boisiae, it shifted compared to gorillas and chimps, right? But what about when you look at Homo erectus, Neanderthals, and Homo sapiens? Did it shift even more? Because you notice that the foramen, you could have said it's in the back, in the middle, or somewhere in between. So did you notice that it was shifted even more? You should have probably seen that. The foramen magnum, which I'm going to just label FM, is further shifted. Further shifted forward. No problem. Okay. What else? Who has a forehead? What about the eyebrow ridges? Anything else that you guys are looking at when it comes to the data that you can put on this tree? Nothing? The post-orbital constriction is when you look at the top of the skull. So here's the top, here's the eyebrow ridge, and if it starts to curve in, that's the post-orbital constriction. So who has that? Okay. Who doesn't have it then? Just them?
And chimpanzees have it slightly, and erectus have it slightly, and Neanderthals.
Well, yeah, kind of. Really all of the members of the genus Homo should have less constriction than the other ones. You guys not see that? So when you look at a gorilla, you see how it really curves in quite a bit? But you look at Homo erectus, it doesn't curve in nearly as much. So there's a big difference there.
Oh yeah.
So what you should have seen is that you look at something like, okay, so here's Afarensis. See how it kind of looks like the gorilla pattern? It pinches in a lot. So you have the eyebrow ridge and it pinches in quite a bit. Kind of looks like this. But when you look at, you can see it pinches in, yeah, but not nearly as much as the other one. So we could say here, PO constriction is less. Now, what do you think that means? What's that an indication of? Right. So we start to see a larger brain. When you look at the brain case of a gorilla and afarensis, does it look the same? Very similar, right? But when we put Homo erectus, what do you see? A huge difference. Okay? So that constriction is an indication of actually how big that brain is getting. It's getting quite large. What about the forehead? Where do we start to see a forehead? With who? What do we start to see a forehead? Where? Australopithecus? Let's take a look. Can you see his forehead? Can you guys see the forehead of the Australopithecus? Okay. Can you see the forehead of this thing? Slightly, right? Okay. So what we could say is we could start to say slight forehead. But who's got the biggest forehead? That's much different, isn't it? Okay. So we could say that large forehead here. Okay? So these three, Erectus, Neanderthals, Homo sapiens, all show a forehead, but a really big forehead is seen only in Homo sapiens. In the other ones, though, we see no forehead at all. Anything else we can put in this tree? Who's got a chin? Okay, so we can put here, chin. Anything else have a chin? No. When you look at the bottom of the jaw now, it doesn't point out. It doesn't point out. It should be the only one should be Homo sapien. Some of you may have felt a bump here. So I'm going to put a question mark because I think some of you were, when you were looking at the data, you may have felt like it looks like Boise might have a bit of a chin, but I'm not really sure about that one. All right. Anything else? All right. So anything else we can put here? What about the zygomatic arch? Cheeks. Where? Where does it start to get smaller? Towards the gorilla side? Big cheeks? Cheeks are these parts. See how my finger go through there? Okay. See, I can't fit. Alright, so what happens as we go towards the genus Homo? Yeah, you get smaller. So as you go this way, the cheeks actually get smaller. So you could probably put down, well actually let's look at it right now. So chimps, big cheeks, I can put my finger through it, right? Let's take a look at Lucy. Big cheeks? Yeah. Okay, so let's look at Boise. Really big cheeks. Look at that. Huge. Let's look at Homo. This one is Neanderthals. Smaller. Let's look at erectus. Pretty big. You can fit my pen through it. So big, small, and then, so where does it get smaller? Yeah, so this way. So maybe somewhere around here, we can say cheek smaller. Okay. I think we have enough information here to answer the questions now. So we had 5 questions to look at. We're not going to look at the introduction because we're going to talk about that at another point, okay? So we're going to look at these 5. So we just made a tree together. So the first question is, what characteristic, now it's plural, but it's only really one that we looked at, did the common, or does the common ancestor of all the specimens have? The teeth pattern. Okay? The dental pattern is the same. Okay. That's the first answer. Second question. What unites the Australopithecus and the genus Homo from the other specimens? So according to this tree, what distinguishes Afarensis all the way to Homo sapiens from the chimps and gorillas? The shifting forward of the foramen magnum and smaller canines. Very good. Okay? That's number 2. Number 3. Based on your data, what would the common characters be that evolved in the genus Homo? So what would the common ancestor of members of the genus Homo, what would it have had? What do you think? Claudia? Yep. Yep, less postorbital constriction, which indicates a larger brain. What else? Start to see evidence of a forehead. The foramen magnum is shifted even further forward. And the dental arcade is curved. Okay? So those are all characteristics that we see in the genus Homo, and we don't really see them in the other specimens. Okay, now there might be a bit of arguing with the dental arcade, because I think it's Afarensis you start to see a little bit of curvature. The suturing, there's a part of the question asks about the suturing. What is significance of the suturing? We actually talked about this before. It indicates that the plates in the skull don't fuse very what? They don't fuse very quickly. Remember, our development is what? Slower. Okay? If the development was really quick and the plates fused very quickly, you wouldn't see those suture lines. Number 4. It says evolution isn't necessarily progressive. Now, that means, progressive means you're heading in the same direction. Can you see an example of where, okay, so let me ask you a question. With the size of the cheeks, do you think they get bigger or smaller as we move from gorillas to humans? Probably getting smaller, right? But let me ask you a question. Boise eye. Right? Where's Boise eye? It's in the middle, right? So as we go from the left side, we have things with really big cheeks. As we go to the right side, we have things with really small cheeks, right? But the thing with the biggest cheeks is Boise eye, and it sits kind of like in the middle of the tree. So you could see examples of where things don't always go from one thing to another. Sometimes you get a reversal where you may see a pattern. For example, in this case, cheek size looks like it's going from really big to really small. But sometimes along the way, something could evolve a reversal. Where have you seen that before? A reversal. You've seen many examples of it. If you look at the evolution of life, living things on land evolved from water organisms from water, right? But what happened to whales? They reversed that backwards. Okay, so there are examples of things that get reversed. Last question has to do with reading this tree. So, afarensis or boisei. You can see that they have chimp-like and human-like characteristics. What would be an example of a human-like characteristic that the afarensis and boisei have? What? They don't have a chin. What is something they have in common with us? What about the canines? Do you see canines? Okay. Do humans have small canines? Do chimps have small canines? No. So is that human-like or chimp-like? Okay. So chimp-like, right? So if you look at afarensis, it has it's human-like. Did I say chimp-like? Sorry, I meant human-like. Afarensis has human-like canines. Well, what about brain size? Very good. Afarensis has chimp-like brain size, especially when you line them up side by side. You can see they're almost the same. So afarensis has human-like and chimp-like characteristics. How do we know? Now I made this tree, okay? So by making this tree, I am telling you that afarensis is more like us than they are like chimps. But if you had to make your own tree, how would you distinguish and determine whether something was more like a human or more like a chimp? Because afarensis is both. It has both characteristics. Its foramen magnum is shifted further forward, but it doesn't have any cranial suturing. So it's got human and chimp-like characteristics. Its dental arcade is pretty straight, kind of more like a chimp than it is like a human. How do you know? How do you distinguish? How do you distinguish if afarensis is more like human? Is it more like a human? No, I know, because I drew the tree for you. But no. I know that, Lauren. I understand. That's because I drew the tree for you, right? But if you didn't have the tree and you had a list of characteristics that were human-like and ape-like, how would you then decide if that thing was more like a human or more like a chimp? I'll give you an example. Tigers. Okay? Tigers have fur, like a mammal. Tigers have a tail. So not a mammal. I meant to say like a primate. Okay. Do you know what the difference between an ape and a monkey is? Okay. An ape is a monkey that doesn't have a tail. Okay? So, let me ask you a question. Let me rephrase this. I give you a gorilla, I give you a tiger, and I give you a lizard. Okay? And I give you two characteristics. A tail and fur. Now, a tiger has fur like a gorilla, but a tiger has a tail like a lizard. Okay? And then I said to you, and that's all you knew. Okay? And then I said to you, what's the tiger more like? Is it more like a gorilla, or is it more like a lizard? Because that's the same problem we got here. How would you know? Yeah, because a lizard is so small. You can't go by that. How would you know? Yeah. I just said it's all you know. It's all you know. You can't use other characteristics. Yep. So you have a tiger. So here's your tiger. Okay. And like a gorilla, so here's my gorilla, it has fur. But like a lizard, it has a tail. So, is a tiger more like a gorilla, or is it more like a lizard? Now, I know, yeah, but it's got other characteristics, like it can make, no, just forget about all that, okay? I'm trying to make a point here. How would you decide? Now, we know the answer. We know tigers are mammals and gorillas are mammals, so we know the answer should be more like a gorilla. But when you pull out a skull out of the ground, you don't have all the information. So, how do you decide? Don't go by. What did you? Don't listen to Mary. There's a very simple answer. Nope. Yep. Huh? Under evolution. No, under a course outline. Human hominid skulls. Lab version 3. Okay. Close. It has to do with age. But not age of the specimen. It's age of the characteristic. So what I mean by that is we have two conflicting characteristics, right? We have a tail and we have fur. Which is oldest? Which of those two characteristics do you think is oldest? Why?
Fish.
Very good.
Yeah!
Because you saw that land animals came from fish-like things with tails, right? And we know that if you put the two in order, tails came before fur. So, the characteristic that's newer came from the most recent common ancestor, or the one that comes after the older common ancestor. So you have to use the newer characteristic, not the older one. So what do you think is newer? What's the newer characteristic? Okay? Small canines, small brain. Which one's newer, which one's older? Small canines are newer, and the small brain is older. And how do you know? There's a quick way. You could go, I guess you could go to Wikipedia. There's an easier way. Look at who has it. How many animals have tails? How many animals have fur? Which category is bigger? Animals with tails, right? Because you have fish, you got lizards, you got reptiles, you have amphibians, and you have most mammals. But who only has fur? Only mammals. The smaller group, so if a characteristic is restricted to a smaller group, it's got to be newer. It's got to be newer. So when you look at all the primates, how many primates have an astonishingly big brain? Living primates. Only one. Us. How many primates have large canines? I think all of them. Except for us. So that's the older characteristic. Okay? Alright? Alright, ladies? So we looked at it, we looked at the data, made a tree, we talked about how to read the tree, we talked about how to analyze the tree. Yeah? Age of characteristics. Yeah. Then you have to do the thought experiment. How many things have it? The more things that have it, the older it is. Yeah. So I'll give you an example, okay? What do you think is older? Having 4 limbs or having eyes?
4 limbs. Eyes. 4 limbs. Fish. Oh, eyes.
Look, how many things have eyes? Insects have eyes. Worms have eyes. Fish have eyes. Yeah. Not all. They do. They have a, yeah. There are, yeah, I'll show you that later. Not all worms, but They all, yeah. So more things have eyes than more things have 4 limbs, which means that's an older characteristic. Okay? All right, ladies? Yeah. But not, okay, that's a good question. Not by majority of number, majority of types. You can have one category, a very small category, but it has like a lot of individuals. It has to be by the number of types. So like eyes, there's so many different types of organisms that have eyes. There's less organisms that have 4 limbs than there are that have eyes. Okay? Now, you could have more organisms with 4 limbs. It's possible, but it's not. But you could, but you got to go by number of types. Okay? All right, ladies, that's it. I'm going to post it right now. The end.